Okay, so here is a problem where you're asked to evaluate this line integral. You're asked to evaluate this line integral over a square. A square is a closed curve, and they've given you the points of the square. Okay, and here I have drawn the square. So evaluate this line integral over this square. Now, since it is a closed since it is a closed curve, this line integral by Green's theorem will be equal to double integration dou psi by dou x minus dou phi by dou y dx dy. Okay? Now what you need to basically do is, you will just have to work out this side. And before that, you need to find what is phi and what is psi. Now, as per your Green's theorem, we have seen that line integral is usually given by phi dx plus psi dy. Whatever is attached to dx is phi and whatever is attached to dy is psi. So, whatever is attached to dx, this is going to be the phi and this is going to be the psi. Clear? Okay. So, when you have phi and you have psi, now the right hand side will be, we have to calculate dou psi by dou x and dou phi by dou y, which we do here. So now I'm only going to be working out the right hand side. So let's go to the right hand side. So this is what we're going to say. By Green's theorem, we have a closed curve, and therefore this line integral is equal to dou psi by dou x minus dou phi by dou y. So we are only going to work out this side. We will get an answer. Whatever answer we get is going to be the answer to the left hand side as well. Now double integration of 3x square y minus 2x dx dy, y being the outer limit, x being the inner limit. Now this is a square, students, and this is a very simple square. You see that x is going from 0 to 1 and y is going from 0 to 1. So for a square, both the limits of x as well as y are both constants. So 0 to 1, 0 to 1. So you all know how to do this integration. The answer that you basically get is minus half. So therefore, by Green's theorem, the answer to this line integral is also minus half. Alright. So the same problem we can solve by verifying. So now the right hand side you have already got. You have managed to get the right hand side as minus half. Okay. So I can pose the same problem to you in a different way. I can say verify. So for verifying, you will have to do even the left hand side. So I will show you that in tomorrow's class.